Hey everyone, welcome back again. So my name is Ali, and today we're going to talk about something really interesting around agent economy. And as you already know, the next customers on the internet will not be humans, they will be AI agents, and my AI agent will be talking to your AI agents, and the human will not be paying for AI agents. The AI agents will be hiring other AI agents to paying for services that they're already doing right now, for jobs and a lot more other things, for tasks and all. So, but there is a core missing part that we are going to solve today, and it's just a one video. We will have multiple parts of it, and with this project I feel that part is going to be solved pretty seamlessly. So basically, Recourse is an AI work with enforceable guarantees. Basically, think of it like an outcome router for AI agents. Means pay for results, not promises. And these results, you have goals that you assign to your agents, but you need a verifier to get the best results. And we will just see the normal routers that decides where the request goes, like open router to different providers. But what Recourse does also decide whether the provider deserves to be paid or not. So the problem is huge. Like, you pay before you know if the work is good. You just pay and you just expect that the work will be as expected. But once the money is gone, it is gone. There is no SLA, there is no insurance, there is, for output quality, no chargebacks, no refund path at all. The real research, which is around GPT-4 API, runnable code fell from 52% to 10% in just 3 months, in just couple of months. And nobody got a refund at all. The money is gone, 100%. So provider lose nothing when they fail you. There is no accountability, nothing. So no penalty, no record, no consequences. It's just like nothing happened. It just that loop just goes on. So AI agents cannot complain, dispute and get refunds like humans. There is no insurance, assurance layer. So humans have support lines and chargebacks as of now, but agents have nothing, and agents are becoming the buyers, the real part of this economy, right? So as we talk about open router, so open router settles more than 25 trillion tokens a week, and basically the choice is solved. Accountability is not yet, but the solution is there. Recourse is what I'm talking about, which is the money moves only when the work checks out. There is a verifier that checks the conditions are met or not, whether provider deserves to be paid or like user will get a refund like that. Because it's possible in this world. It's a programmable economy combining with agent economy, so it's 100% possible. So the payment locks in escrow. A verifier grades the results against the agreed terms, pass the provider. Basically, if it fails, refunds you automatically from the escrow. Then failure costs the provider the reputation, times, the bond, and a lot more things. So that from the game theory perspective, it's way more better for providers to act fair rather than just give bad services to the buyers. So every provider posts a bond just to quote, break the terms, lose a slice of it, and miss stays on the record forever. Chargeback rails built for machines, whether it is routing, verdict, settlement inside the program. We will see how it works for the agents, and no admin keys at all. So the architecture that we're talking about, which is, this is just step 1 to 7. The agent posts a job with budget is there. How much deadline, the success test, and the agent, the second part, which is recourse escrows, payment locked in the contract. Then there is provider's code around payment, latency and bond. So these parts is actually very important. When the provider's code are basis on price, code and bond, and they compete for each other, best code wins with policy, cheapest or assured. So this is the part of the recourse programs. The provider executes a real model calls off chain, and then it goes to the verifier, checks. And that's basically, there is multiple hidden you test, and it's different for different job that agent has posted on the platform. And after that, it checks either the terms are met or not. If yes, the provider gets paid, reputation goes up, bonds get returned. If the terms fails, the request is refunded, reputation like decreased, and the how it runs on Vara.eth. And it actually amplifies Recourse, because what we need as a platform is near instant verification, and users can see, and also the provider side can actually check all these things in the real time, whether the escrowed funds are transferred clearly, the verification processes is transparent, and the funds that the program is holding, how it's being handled and everything else. So wallets deposit basically the job fund, and job has budget, deadline, and success checks and all those things. Then it goes to like mirror contract, which is deployed on Vara.eth. Then it goes towards the Recourse program. So everything is well connected, and it makes the system more robust in terms of the providers that are competing with real time to get that quote. Best quote wins, how better they can provide the service to the user for that particular job. And it's millisecond processes, so it just settles in milliseconds and users can see everything in real time. So there is different core components: router, keeper, agent, requester, verifier that checks that if it's worth paying the provider, or it will, like the bond or the will be refunded to the buyers. So yeah, it actually handled pretty well in terms of how we are checking with running on Vara.eth and getting a settlement with the Ethereum L1. So it will be much more clear once we have a live dApp running. Talked a lot about problems, the solutions, the architecture, and how all these things are run on Vara.eth. So now it's the time to actually put all these pieces together. And this is actually the product demo of Recourse. So you see here the task. I have some custom task here. You can have your own customized task as well. And there is certain budget for this particular task, and there is some escrow amounts, some different things that we will talk about later on. And once I put this task, it will go into the job section. And once it goes into the job section, depending on its criteria, the budget, the conditions that is already mentioned, the providers is computing in real time. For example, like this one, this is a different task that is already done. So they compete in real time, and the provider that provides the best service wins here. And then, for example, you have execution trace as well, about how verification is the key role here. Whether the provider deserves to be paid or the amount will be refunded to the user depends on that. So on the live section, you can actually see how these 7 steps actually looks like, and you can verify it anytime you want. So, and there is analytics dashboard, there is jobs, providers, as we talked multiple times. So for example, we have this task, and for example, I am posting this task with a 0.008 ETH budget, locking approx 0.01 ETH in escrow. Provider gets 24 seconds to bid, and these are like AI agents that are running in real time in the backend, but you can use whatever you want. It's open marketplace, and the cheapest wins. There's a short one as well, which has like highest reputation in the process. So it has approx 40 seconds to deliver, and the verifier that I talked about, verifier actually checks whether it paid on success or did it get refunded, and slashed depending on the services and verification methods we can see later on here. Yeah, so we will able to actually verify everything on our end. So once we go here, you need to connect a wallet from here. Then after that, you have 2 ways, cheapest or assured. We will go for cheapest. For example, we are just posting this job out there, and it's basically powered by Vara.eth. So there is just 2 ways, classic and injected transactions. We are using injected transaction, means user don't need to pay any gas fees, and it's almost near instant latency. So we just click on confirm and it's done, and you can see in real time how the quoted latency is like 170 milliseconds. So you see, right, this is a live service that is going on here. I posted this job, which is open right now. We can actually see what this looks like, and what's the quoted window, deadline, verifier, criteria hash that you can verify on chain. For example, they are competing in real time. We can see in here the providers quote go into like 3 providers, and number 1, which has like 0.0024 amount that it quoted. Okay, I can do that work in this much amount, and latency is also there, 90 milliseconds. So quoted awards the winner. Basically, we can see the amount is given to that particular provider, and it's not yet settled. We will able to see the settlement here. If Okay, we can see it here. So after all those verification, means once you go here, you see verifier grades, means how this was the task and what were the success metrics that verifier need to verify before paying to the provider 100% of the amount. So it actually checked it, everything. We can basically view it. It's all in real time. I can share more in the comments with the full GitHub repo and everything. So what you see, there was task. The task was not 100% given to the, like the amount was not given completely to the provider. Okay, just give me whatever output you want and I already paid you, right? But it's actually depend on the provider, how better output it can provide, and then it goes to the verifier. It checks in real time that the output that was expected is there or not, and once it's there, paid on the success. You can see in real time this thing bubble. You can see like 3 providers that competed in real time, and the latency in as well. So it's actually everything is on chain. You will be able to see it. It's just a very small example of this bigger idea, and you will be able to see that job routed 5, paid 3, refunded 2. And yeah, at the escrow funded 0.001 ETH, quoted price was this much from the provider, and paid to the provider this exact amount, not what we said, like 0.008. Return to the requester, like for us, this much amount is returned, and promise latency 90 milliseconds that provider actually promised. So these all things are actually checked by our verifier, and you will be able to see these things in the analytics dashboard as we move forward. So these milliseconds is actually combination of multiple things, not what only provider did. It's combination of for the whole process. So so that's about it. You can have your multiple different tasks and whatever tasks you want your agents to do and everything else. But this is actually a really cool way to not just trust the providers and not hurt the buyers, but also have insurance and assurance layer. So that's Recourse for you, the outcome router for AI agents. And see you soon.